The force required to stretch a piece of bungee cord, it was recorded in the graph below. Calculate the work done when a 60 Newton force is applied to the cord. Okay, so what is generally a good idea? If you don't have a nice triangularly shaped graph, what do? Count the squares. Work out what one square is worth, and then count how many squares you need to count. So in this case, if we have a look, let's look at the only full square down here. No, I don't like black. Let's do red. This is our only full square. Oops, there. Okay, so it is like this. We have 0.5 across the bottom, 0.5 meters, and what are we worth up the side? 20 newtons. So each square is going to be worth, our work done for each square, 20 times 0.5. So each square there is worth 10 joules of work done. So now we just count the squares. Now a good rule of thumb, if they're difficult to count the ones that have more than half shaded. Okay, if you're not sure, count the ones that have more than half shaded. So if we have a look, now you can make some estimations here. I would say that these three look like about 2 squares worth to me. I think they're all missing about a third. So we'll count that as 2 squares, call that 2 squares as well, because that little triangular piece might fit into there. It's got another 2. It's going to mess us up, isn't it? Well, let's be nice and call that we'll call that 0.5 of a square. This is probably more accurate than you need to be. On an exam, you just need to show people what you're doing, and it'll be correct. Okay? If you're counting this as 2 squares, just show them that you're counting it as 2 squares. As long as you're not being outrageous in your assumptions, it'll be fine. So what do we have? 2.5. Hang on, 2 there, half there. So we've got 4.5 squares. Each one is worth 10 joules. So our work done is going to be 45 joules.